So today we are looking at physical versus chemical changes in matter. Our essential question would be, how can I differentiate between physical and chemical changes in matter? As a review, matter is anything that has mass and volume. Takes up space. Atoms are the building blocks of matter, and molecules are two or more atoms that are joined together by chemical bonds. Let's start with physical change. So a physical change is a substance that does not change the chemical makeup of the substance. For example, if you break a watermelon, you are changing from one big piece into multiple smaller pieces, but you still have the same substance. It's still just watermelon. Another example, ice cream melting. That's just an example of changing from one state of matter to another. So, from a solid to a liquid. Again, there's no chemical change. It's just melted ice cream. Some characteristics of physical changes. In melting, you go from a solid to a liquid. It changes shape. The temperature, of course, changes. In freezing, you go from a liquid to a solid. The shape again changes, and the temperature also changes. In vaporization, you're going from a liquid to a gas. The shape changes and the temperature increases. When you're talking about crushing something, you're just taking a block of something and crushing it up. There is no chemical change. Same thing with breaking. The shape changes, but nothing else changes. Condensation is when you go from a gas to a liquid. So the shape changes and the temperature decreases. So with physical changes, a key thing to remember is that the substances stay the same, but the shape, size, or form differ. So there's no chemical change, no chemical bonds, no new substance. So we have to review the three states of matter real quick. You probably remember this from grade 8. So there are three states of matter that we look at, primarily solids, liquids, and gases. So every piece of matter that exists in the universe is either a solid, liquid, or gas. Phase changes indicate changes in the particles or how they move in the substance. So you can change a solid to a liquid by heating up the substance, and it'll make the particles speed up. So they speed up when you add heat. Solids have structural rigidity and resistance to changes of shape or volume. Their particles are tightly packed. They vibrate. They're very tight together, but they vibrate. Liquids are the only state with a definite volume. That means they take up shape, but they take up space, but they have no fixed shape. Their particles are tightly packed, but are far enough that they can slide past one another. So let's go back to the only state with a definite volume but no fixed shape. Liquids take on the shape of their containers. So if you add heat to a solid, you get a liquid. Gases are made up of individual atoms, elemental molecules made up from one type of atom, or a compound of molecules made of a variety of atoms. The key thing to remember here is that they have indefinite shape and an indefinite volume. So they take on the shape of their container and the volume of their container. The particles of gases are very far apart, and they move very freely when they're trapped in a container. So again, if you add heat to a liquid, you get a gas. There is no chemical change. If you take a pot of water and you boil it on the stove, it changes from a liquid to a gas, but there's no new substance. So if you look at the different phase changes and what happens to the heat and energy, if you go from a solid to a liquid, then that phase change is called melting, and you have added heat and you've added energy. A liquid If you go from a liquid to a solid, then the phase change there is freezing, and you have taken away heat and energy. If you go from a gas to a liquid, that's called condensation. You have, again, removed heat and energy from the substance. If you go from a liquid to a gas, that phase change can be called vaporization, boiling, evaporation. But what you've done is you've added heat and energy. You've not changed the actual chemical makeup. From a solid to a gas, that is called sublimation. And that is adding heat and energy. And from a gas to a solid, that is called deposition, not sublimation. We'll talk more about that later in the year. But either way, you've subtracted heat and energy. So these are all physical changes. And one of the hardest things for students to remember is that if you go from a solid to a liquid, or if you experience any kind of phase change, that is strictly a physical change. There's nothing chemical about it. So the freezing point and the melting point can sometimes be the same. And what I mean by that, the freezing point of water is 32 degrees Fahrenheit or 0 degrees Celsius. But that's also the melting point of water. So what that means is if you take ice cream and you put it in the freezer, it's not frozen when you put it in there. So once that temperature gets down to 32 degrees or 0 degrees Celsius, it starts to freeze. On the other hand, if you take the ice cream out of the freezer, once the temperature gets up to 32 degrees or 0 degrees, then it's going to start to melt. So you can actually have two different states of matter at the same temperature. Now let's look at chemical changes. Chemical changes produce a new substance. That is a key concept. You have to remember that chemical changes produce a new substance every time. So in other words, a chemical bond has occurred. Change that results in the formation of a new product, that's a chemical change. Examples, a rusty car. You've got metal and you've got oxygen, and those two things react together to form iron oxide, also known as rust. If you take sodium metal and chlorine gas, they react together to form sodium chloride or table salt. So that's a new substance. When you digest food, your food is broken down by stomach acid. So what was food is now something else. So anytime that you have a change and you get a new substance, then you're looking at a chemical change. So if you are, these are some key words to let you know that a chemical change is taking place. Burning, rusting. If something happens or reacts and you get a new color, I'm not talking about painting a wall, that's physical. But if you put hair dye on your hair and your hair changes color, that is a new color. If the leaves in the fall turn from green to red, that is a chemical change. If you have something that reacts in a bubble or gas forms, for example, if you put vinegar and baking soda together, that bubbles and creates a new substance, that's a chemical change. If you take an Alka-Seltzer and drop it in water, those two things react and you get new bubbles. On the other hand, if you take a straw and you blow into your soda or milk and it creates bubbles, that is a physical change only. You are physically creating those bubbles. If you have a liquid, two liquids together that form a solid, that is an indicator of a chemical change. Sorry, that's my puppy. Sorry, I had to get my puppy calmed down. So back to chemical changes or chemical reactions. This is a process by which elements and compounds combine to form new substances. So there's that those two words again, new substance. That lets you know that it's a chemical change. Examples again, rust, batteries, burning wood. Anytime that a new substance is created, then you have a chemical reaction or a chemical change. So just in recapping, if you are talking about a physical change, you are talking about things that can be undone. You are talking about things where there is no new substance. Example, if you take a piece of paper and you tear it into strips, you can physically tape that paper back together. If you crush a can, that is a physical change. You do not have a new substance. If matter changes state, so if a substance evaporates, for example, that is a physical change. It is still the same substance, it's just in a different state of matter. And then chemical changes, you can always tell when it's a chemical change because you get a new substance. Some examples of words that would indicate a chemical change is the formation of bubbles during the process, burning, rusting, reacting. Any of those words would indicate a chemical change. So hopefully after viewing this PowerPoint, you understand the difference between chemical changes in matter and physical changes in matter.